All right, Miss Teasley here. We're starting a new unit. This unit starts off with quadratic functions. And you were introduced to quadratic functions in the last unit. It was one of our parent functions. So we have it here, y equals x squared. So this is a quadratic function. Quadratic has the highest exponent of 2. So you're going to see a x squared in the problem. But we're going to really focus on the graphing in this section. So starting off, let's talk about the graph of a quadratic function. All right, the graph of a quadratic function is called a parabola. So the graph is called a parabola, which is a U-shaped graph. So a U-shaped graph. Move this over some. So U-shaped graph. All right, so the parabola is going to either open up or open down. So let's look at the different ones. You have the one that opens up, and you have one that opens down. So these are your two possible quadratic functions. The turning point, when a graph changes from increasing to decreasing or from decreasing to increasing, that's the turning point. That's called the vertex. All right, when the parabola is open up, the vertex is called the minimum. All right, the minimum point. And we say min for short. When the parabola opens down, the vertex is called the maximum, or max for short. Now, we can determine whether our parabola opens up or down just by looking at the equation, and we'll talk about that in a moment. I'll come back to that opening up and opening down, but let's look at the basic quadratic function. All right, go back to what we learned. So this is graph f of x equals x squared. We're going to just use a table of values like we did in the past, and we're just going to sketch 3 points. -1 using x equals -1, x equals 0, and x equals 1. To get the y value, I need to square 1. All right, so this is y equals x squared. So -1 squared is 1. 0 squared is 0. 1 squared is 1. So I'm going to sketch this quadratic function. So we'll say that's -1 and this is 1. 1 and -1. We're just doing a rough sketch. At -1, there's a y value of 1. At 0, there's a y value of 0. And then at 1, 1. Right, so here is our U-shaped graph, our parabola. So that's the parent function. The vertex is called a min. All right, so the vertex is a minimum. That's a question that you'll be asked. Vertex is a minimum. The actual vertex itself is the origin, which is the point 0, 0. We're going to use transformations and Y-intercepts to help us graph some of the quadratic functions in this particular section. But let's talk about this a value. So if you notice in this example 2, you have this x plus 4 squared minus 1. All right, let's talk about the number in front of the parentheses. So when you graph a quadratic in this form, or vertex form, it's going to look like this. Y equals a, x minus h squared plus k. Oops. So x minus h is in parentheses squared plus k. And we're going to be focusing on this a value. This a value tells you whether the graph opens up or down. So if a is greater than 0, so numbers that are greater than 0 is positive, If a is greater than 0, then the parabola opens up. Let me move this over so hopefully I can do that. Oh, nope. All right, the parabola opens up. See if I can get this to move over some so we can fill in the information. So we're talking about a generic parabola. Y equals a, x minus h squared plus k. If the a value, which is the number from the parentheses, if it's greater than 0, the parabola opens up. So it looks like this. If a is less than 0, then your parabola opens down. So that's your upside down parabola. So upside down. So we get all that just from looking at the equation. Now right here where it says vertex, let me just highlight that. That goes here. That's this value. So for the first example, they kind of have a little space so we can write the vertex, which is the origin 0, 0. So I didn't want to skip over that part. But let's graph some parabolas. We're going to be using the vertex, and we're going to use the Y-intercept to get the graph of our parabolas. And when you do this in my math lab, that's exactly what you're going to have to use. You're going to have to use the vertex, and you're going to have to use the Y-intercept. So here, looking at the first example, or example 2, first thing I already know is that a equals 1. So that means my parabola is going to open up. So if it opens up, this vertex is a min. All right, that's a question in itself. What is your vertex called? What type of vertex do you have? It's a minimum or min. To get the vertex, let's use transformations. We talked about transformations in the previous lesson, in the previous section. So notice in parentheses I have an x plus 4. Well, that plus 4 means that the original parent function, all right, shifts 4 units to the left. And then that minus 1 means that the graph shifts 1 unit down. So now remember, your parent function is the one we graphed before in example 1. The vertex in the parent function starts at 0, 0. But our vertex, now if you take that vertex that was at the origin, we're going to shift it 4 units to the left. So 1, 2, 3, 4. 4 units to the left. And it's going to shift 1 unit down. So negative 1 down. That's the location of my vertex. That's my V value. That's my vertex. So just by me using transformations, I know that the vertex of this parabola is going to be negative 4. That's a negative 4, comma, negative 1. Using transformations. We already know that the graph is going to open up. The vertex is the turning point. To get another point, we're going to use the Y-intercept. All right, so again, you're going to have to do this in my math lab. The Y-intercept, remember, to find the Y-intercept, you let x equal 0. So you go to the original problem. F of x equals this x plus 4 squared minus 1. Remember, f of x is just another way of saying y equals. So y equals, wherever I see an x, I'm going to put a 0. So 0 plus 4 squared minus 1. When I simplify this, this is 4 squared minus 1. 16 minus 1 equals 15. This means that my graph is going to cross the y-axis at 15. All right, I'm going to cheat and just say that's 15. So to get a rough sketch of this graph, I know that's going to cross the y-axis at 15. It opens up. So this is a sketch of our parabola. All right, let me just put this into Desmos so you can see how all this stuff lines up. So x plus 4 squared minus 1. So y equals parentheses x plus 4 quantity squared minus 1. Notice how the vertex is at -4, -1. It opens up and then it crosses the y-axis at 15. And that's all you would need to sketch the graph. All right, let's do another one together. So here, I'm going to graph this function. Let's talk about this a value. In this example, a equals 2. Since 2 is a positive number, that means my parabola is going to open up again. So there's your open up. The vertex is a min. Or minimum. That's what short for minimum. And from this equation, we can get our vertex. We'll talk about it using the graph transformations or translations. And I'll show you how you can use the equation to find your vertex. But remember, using transformations of functions, we have a -5 in parentheses. So since that's a -5, that means my graph is going to shift 5 units, right? And the +3 at the end means it's going to shift 3 units up. And when I say it shifts, I mean the parent function. The parent function, y equals x squared. In this case, y equals 2x squared. It starts at the origin. This vertex, this new vertex, is going to shift 5 units to the right. So 1, 2, 3, 4, 5. And it's going to shift up 3 units. 1, 2, 3. So this new vertex is here. So I'm going to put V for vertex. So when they ask me for the vertex, just reading this point off the graph, my vertex is at the point +5, 3. Another way that you can get the vertex without using translations is if you look at the original, if you look here, let me highlight it. Well, let me put a box around it. So I'm going back up to the top here, putting it in blue. That y equals a x minus h squared plus k. Well, the vertex is going to be h comma k. I'll put it below it, h comma k. So notice how it has a minus h. That means that this minus means it's the opposite of the h value. So the vertex has an x coordinate of +5. So that's where that 5 comes from. That's my h. And then the last number, that plus number at the end, that's your k value. So that's your hk. So you can also just look at the equation and determine the vertex by using the opposite of what's in parentheses, comma, whatever that last number is, that up-down number. To graph this, and remember you're going to have to do this in my math lab, you're going to have to graph the vertex, and it's going to say graph an intercept. The easiest intercept to find would be using the Y-intercept. So we're going to use the Y-intercept. Again, to find the Y-intercept, you let x equal 0. So here I'm finding my Y-intercept. So y equals 2 parentheses 0 minus 5 squared plus 3. So this is 2 times -5 squared plus 3. -5 squared is 25. So this is 2 times 25, which is 50, plus 3 equals 53. So your y-intercept, your graph is going to cross the y-axis at 53. Now again, I'm just doing a rough sketch, guesstimate. I'm going to say that's 53. So my parabola looks something like this. Now I'm going to use Desmos to actually do the actual graph, but that gives you an idea what your graph is going to look like. All right, so let's put this into Desmos. X minus 5. So this is y equals 2 parentheses x minus 5 squared, and then there's a plus 3 behind it. So the vertex is at 5, 3. So remember we got that 5, 3. And the y-intercept is 53. So I'm just going to scroll all the way up so I get to my 50s. And if I hit the y-axis, there's your y-intercept, 0, 53. And it opens up. So all that you should be able to determine just by looking at the actual equation itself as far as whether it opens up or down. And then you should be able to find the vertex. So now I'm gonna now this will be a good time for you to pause and you try this example. So you try. So try this example and then we'll come back together and work it out. All right. So hopefully you paused the video and you tried this example. So let's go through all the steps again. First thing, you want to determine whether it opens up or down by looking at the a value. A is -3. So since a is a negative number, it's going to open down. You're going to have an upside down parabola. And in this case, the vertex or the turning point is going to be a maximum. So vertex is a max or maximum. So I already got an idea what my parabola is going to look like. You can find your vertex by using transformations or just by looking at the equation. I'm going to first talk about transformations. The transformations or translation, this graph shifts left, right, up, down. The translation is that -3 means that the graph is going to shift 3 units right. So the parent function, the graph that originally starts at the origin, is going to shift 3 units right. And that -1 at the end means it's going to shift 1 unit down. So if you kind of sketch a graph, I know that it's going to shift 3 units to the right. So 1, 2, 3. And 1 unit down. So it looks like it's going to shift. Make this 3 a little bit smaller. So it's going to shift here. This is my vertex. And it's going to open down. So looking at the graph, my vertex is the point 3, -1. Remember, the opposite of h is in the parentheses. So if you notice the h value, so you have x minus 3, h is 3. This is your h. And your k value is that last number, which is -1. So you could just look right at the equation again and find your vertex. Now let's find the y-intercept. We already know that it's going to open down. I know I have to probably move this graph up. Let's move this up a little bit. So let's find our y-intercept. Again, to find the y-intercept, you let x equal 0. So this is y equals -3. In place of x, I'm going to put 0 minus 3 squared minus 1. So this is -3 times -3 squared minus 1. This is -3. So -3 squared is +9. All right, minus 1. And then I need to do -3 times 9, which is -27. You still have that -1 behind it. And when you simplify, you get -28. So my graph is going to cross the y-axis at -28. I'm going to cheat and say -28 is here. So my graph is going to look something like this. This is just a rough sketch of the graph. And again, that's all you have to do in My Math Lab. You just have to select the vertex, the y-intercept, choose the little parabola shaped graph, and then you'll have your graph and you'll get full credit, or you'll receive full credit. And let's just check this again. I'm going to put this into Desmos. -3 x minus 3 squared. So y equals -3 x minus 3 squared. Oops. And then there's a -1 behind it. So notice last time I moved my graph so I can get up the I had a Y-intercept of 53. Well, whenever you want to reset your Desmos, whenever you hit this home button over here on the right side, the little house home, it takes you back to your original window. So notice how my parabola is open upside down. If I click on the vertex, that's the vertex 3, -1, which we already established. And then let's look at the Y-intercept. If you go down here, the graph crosses the Y-axis at -28. So we did it correctly. So hopefully you understand how to graph the parabola in what we call standard form. So this box right here talks about the standard form. I already talked about this A value and then the HK. So that's standard form. And then we want to graph a quadratic if it's written in general form. So again, we're going to still have that A value that we talked about. But notice this time, A is going to be the number that's in front of x squared. And then to find your vertex, you're going to have to use this vertex formula, all right? Or the axis of symmetry formula is what it's called. So this is the axis of symmetry. And I'll kind of explain that. So the axis of symmetry, first of all, to find the axis of symmetry is the x coordinate of your vertex. So let's make a note that this is going to be the x coordinate of the vertex. It's also the equation of the line that goes through the vertex, the vertical line, the axis of symmetry. But the formula that you need to know is x equals opposite of b over 2a. When I talk about opposite of b over 2a, I'm talking about the b that's in front of x and the a that's in front of x squared. To find the vertex, once you get that opposite of b over 2a, that's your x value. To find the y value, you have to plug it into the original problem. So negative b over 2a, f of negative b over 2a, or opposite of b over 2a. All right, it looks more complicated than what it is, but this is how you would see it probably written in a textbook or see it written in my math lab. All right, but I'll explain to you how to do all this. So again, we're going to go through the steps as far as whether it opens up or down. Well, first of all, I see that there's a 1 in front of x squared, so I already know that a equals 1. Since a equals 1, that's a positive number. That means my parabola is going to open up. So open up. Or opens up. Now we want to find the vertex. So we can't just look at the equation and identify the vertex. We have to use the axis of symmetry. So let's go to the next step, which is the axis of symmetry. And you'll be actually asked to find the axis of symmetry when you're doing your homework in my math lab. So to find the axis of symmetry is an equation. And the formula is x equals the opposite of b over 2 times a. Well, the opposite of b in our case, b is 8, so this would be negative 8 over 2 times the a value is 1. So this is negative 8 over 2, which equals negative 4. So our axis of symmetry, if you're asked what's the axis of symmetry, it will be x equals negative 4. You have to type it in as an equation. It's the vertical line x equals negative 4. What does that look like? Well, oops, sorry about that. So if you go to negative 4, x equals, we talked about graphing equations of lines in the last unit. X equals negative 4 is this vertical line. It's like an imaginary vertical line that goes through the vertex of your parabola. So basically, once I graph my parabola, if I fold my paper along that pink line, then it's symmetric. Both sides of the parabola will meet up. That's what the axis of symmetry is. That's the equation. The good thing about the axis of symmetry is that it's also the x coordinate of your vertex. So I already know from my vertex that the x coordinate is negative 4. What I don't know is what the y value is. Well, to find the y value, you need to find f of negative 4. So f of negative 4. Well, what's f of negative 4? You go to the original problem, which is f of x equals x squared plus 8x plus 15. In place of x, you're going to put in negative 4. So first thing is we take the x out the picture, put some blank parentheses in place, and inside all the parentheses, we're going to put -4. And then we simplify this. -4, remember you only deal with the right side. -4 squared is 16. And this is +8 times a -4, so that's -32. And you still have that plus 15 at the end. Now you go from left to right. 16 minus 32 is -16 plus 15. -16 plus 15 is -1. So this is your y coordinate of your vertex. So your actual vertex in this space down here where it says vertex is going to be -4. Again, that's the same value as the axis of symmetry, and -1. So on this vertical line, -4, -1 is actually the vertex. So the vertex would be here. That's my vertex. We already know that it's going to open up. We need to find the Y-intercept. So the Y-intercept is fairly easy when it's written in this form. The Y-intercept is when you let x equal 0. So see what happens when I let x equal 0. Y equals 0 squared. Oops. So taking the original equation, y equals 0 squared plus 8 times 0 plus 15. Well, if you notice, you get 0 plus 0 plus 15, which is 15. So the Y-intercept is 15. The Y-intercept is always going to be, when it's in this form, the Y-intercept is going to be the C value. So let's make a note. The Y-intercept, when it's in this form, and I should go back to the box. So let's go back up here to the box. So to make yourself a note that the Y-intercept is going to be Y equals C, which is whatever, that's when it's in general form. So that last number, the constant. So without any work, you can just look at the last number and know that that's your Y-intercept. That only applies if it's in standard form, when it's multiplied out. It's not as simple as it is when you do it in standard form. A little bit more work. So y equals 15. So that means my graph is going to cross the y-axis at 15. And I would just sketch my graph. It's symmetric. The axis of symmetry is this line, x equals -4. And if they ask you to give you this, if they ask you to give this in my math lab, you have to write it as an equation. X equals -4 is the axis of symmetry. So again, that means if I fold my paper along that pink line, it will be symmetric. All right, both sides of the purple will meet up. All right, I'm going to put this into Desmos. X squared plus 8x plus 15. So y equals x squared. X squared plus 8x plus 15. So I'm going to hit the home button. So I have a vertex of -4, -1. We saw that. And it crosses the y-axis at 15. That's your y-intercept. And let's even graph that vertical line, the axis of symmetry. X equals -4. So you can get an idea. So notice how that black line cuts the parabola in half. It's symmetric. If I fold my paper along that bold black line, both sides of the purple would meet up. All right, we're going to do more example, and I'm going to let you try this. So this would be your example. You try this. So pause the video and try to do this example based off of example 5. All right. So again, hopefully you had a chance to try this example. A in this example is also 1. So it's going to open up. If that was -1, it will open down, just like before. But A is 1, so that means that it's going to open up. And if it opens up, that means that my vertex is a min. All right, your vertex is a min, that turning point. So I already established that. The next part is, well, what is the vertex? Well, to get the vertex, you start off with your axis of symmetry. The axis of symmetry formula is x equals opposite of b over 2a. So to find my axis of symmetry, x equals the opposite of b. In this case, b is 6, so this would be negative 6 over 2 times the a value is 1. So negative 6 over 2, which equals negative 3. So my axis of symmetry is the equation x equals negative 3. This is also the y-coordinate of your vertex. So, the x-coordinate of your vertex. So here's my vertex. My vertex is going to be negative 3, and then whatever f of negative 3 is. That's what we need to find. All right, so what is f of negative 3? To find f of negative 3, you use the original equation. F of x equals, everywhere I see an x, I'm putting in a blank parentheses. And inside the parentheses, I'm putting negative 3. You only simplify the right side. Negative 3 squared is 9. Positive 6 times negative 3 is negative 18 plus 7. 9 minus 18 is negative 9 plus 7. Negative 9 plus 7 equals negative 2. This is my y-coordinate of my vertex. So therefore, my vertex, I'm going to write it down here, is going to be negative 3, comma, negative 2. The y-intercept, remember, is just y equals c. So my y-intercept is going to be y equals, and our c value is 7. So y equals 7. So it's going to cross the y-axis at 7. And so now you should be able to do a sketch or create a sketch of your graph. All right, x equals negative 3 is the axis of symmetry. So let's say 1, 2, 3. So here's your vertical line, the axis of symmetry. The vertex is actually at negative 3, negative 2. So here's my vertex down here. It opens up. It's going to cross the y-axis at 7. That's all you need is just the vertex and the y-intercept, and you'll have your curve. Again, let's check this. X squared plus 6x plus 7. Y equals x squared plus 6x plus 7. Y-intercept is 0, 7. Vertex is negative 3, negative 2. Axis of symmetry is x equals negative 3. That vertical line. All right. And that's it. We're going to just stop there. That's graphing or quadratic functions, graphing quadratic functions. All right, so you have some more examples here that you can try for practice before you do your homework, and just check the graph using Desmos.